All right, one-to-one functions and inverse functions are what section 6.2 talks about. So we got a few definitions to hit up here at the beginning and talk about. So one-to-one functions and inverse functions. We're not departing away from composition. We'll use that some as a tool when we're talking about one-to-one and inverse functions. Don't think we're done with composition, because we're not. We'll use it in this section. Okay, what is a function? What makes a relation or a set of ordered pairs or an equation a function? What was it? X's don't repeat. All right, so if it's a list of ordered pairs, it's easy to tell if X's don't repeat. But what if it's an equation or a graph? Well, what did we use to test that? Vertical line test. Those are the things that we've done to decide if something was a function or not. That was back chapter 3 stuff. Okay, a one-to-one function. The difference in it and a regular function is that it is a function of x, and then if you swap the x and the y, it's also a function of y. So it's no repeating x's, that makes it a function, or y's, that makes it a one-to-one function. Okay, so it passes the vertical line test because it doesn't repeat x's, and then it's going to pass a horizontal line test. With the same rule. So vertical line test, it can only hit once, right? Horizontal line test is the same rule. It can only touch one place anywhere on the graph, and it passes the horizontal line test, and that decides if you repeat y's or not. So one-to-one functions are going to pass the vertical line test and the horizontal line test. Has to pass both to be a one-to-one functions. Okay, one-to-one functions are pretty special in the fact that they're inverses. They are functions. So one-to-one functions have inverse functions. That doesn't mean that every regular function doesn't have an inverse. It just means that the inverse isn't always a function. So a one-to-one function, the original function will pass the vertical line test and the horizontal line test. When you find the inverse, and we're going to talk about doing that today, the inverse function will pass the vertical line test and the horizontal line test. So we can find inverses for things that are not one-to-one, but that doesn't necessarily mean that the inverse is a function. A one-to-one function, you'll get a function of the original, and the inverse is also a function. So that's one-to-one is pretty special in that. All right, and an inverse function, so the next definition there is an inverse function, and then we're going to get into doing something here. So inverse functions interchange the domain and range. So if you find the inverse, it interchanges the domain and range. Best way to say that in layman's terms is swap x and y. Domain is x, range is y. So when you do the inverse function, then you're swapping x and y. That's what you're doing. So really, really easy idea there. Gets a little bit more complicated when we get to a little less concrete examples. But one-to-one functions got to pass vertical line test, horizontal line test. If it is one-to-one, the inverse will be a function. And then inverse functions, if we go to find an inverse function, we're swapping the domain and the range. X becomes y, y becomes x. So we're interchanging the domain and the range out of that. So what we're going to do is we're going to do a couple examples here. It is the function 1-to-1. If so, find the inverse. We're going to start off with a really easy one, but for some reason, sometimes these trip folks up. But it's not hard. It's a set of ordered pairs. So nothing just crazy hard here. They use the function notation here, so we should take that as gospel truth, right? That's a function, but we know how to check that if it's a function, right? With the x values, do the x values repeat? No. Okay, then we check for one-to-oneness of that. We look at the y values. Do the y values repeat? No. So is this 1-to-1? Yeah, this is 1-to-1. And we're going to find the inverse. The inverse swaps the domain in the range. So it swaps x and y. So since we're dealing with ordered pairs, it's straight up that kind of swap. Boom, turn them around. So the first ordered pair, instead of being -3, 6, is going to be 6, -3. The second order pair is going to be 7, -1. Third order pair, 13, 2. And the last one, -8, 5. That is the inverse function. Now the notation for inverse is f, looks like a little -1 exponent. So f inverse of x is what that's read as, but it really is a -1 exponent right there in the notation. Okay, so we're writing the inverse. That's the notation we're going to use when we're using inverse functions. Okay. All right, so 1-to-1 functions, no repeating x's, no repeating y's if it's a set of ordered pairs. That's too easy. Let's go to something harder. But not too difficult. Let's do f of x is equal to 6x minus 7. Is that a function? Why? It's linear. And a slope of 6, right? So it's going up and to the right, which means it would pass the vertical line test. Would it pass the horizontal line test? Yes. Okay. If we're not sure, we got a graphing calculator. Use the thing. 6x minus 7. A graph. So we see that we could do the vertical line test, horizontal line test on the graph. We got a graphing calculator that can help us determine.
At this time, we need Miss Madge and Miss Hessing's Biology 1 classes to report to the library.
Is there anybody in Biology 1? That fun thing. We're going to be in the first block until they're finished with that test. I don't know how long that'll be. They talk like it wouldn't be too long. So 75 minutes from whatever time they get started. So anyway, so got an equation or a function. We can check the graph, do vertical line test, horizontal line test. That tells us if it's 1-to-1. So this is 1-to-1. Now, the difference here is that we don't have a set of ordered pairs. We have a representative for a set of ordered pairs. Remember that line that we graph there is all of those ordered pairs that fit this pattern. So we've got to find the inverse function of this. Okay, so really easy to do. We set up. I'm just going to change, instead of writing f of x over and over, I'm going to change that to y. So the original problem is y equals 6x minus 7. What do inverse functions do? Swap x and y. So we're going to swap x and y in the problem. And then we're going to resolve it for y. So first step would be add 7. So x plus 7 is equal to 6y. And now what? Divide everybody by 6. And there we're going to get y equals 1/6 x plus 7 over 6. Let's write it in function notation. The original was f of x, so I'm going to write f inverse of x equals 1/6 x plus 7 over 6. And there's the inverse function. That seems too easy, right? It is. It's going to be a little more difficult. But first thing, checking for one-to-oneness, if we can visualize 6x minus 7 because we've been doing linear for a long time. So that's easy to do. Let's do something we don't visualize quite as well. Like f of x is equal to 2x plus 1 over x minus 1. X does not equal 1. Okay. So this little add-on here is just domain stuff. We know x can't be 1 for that function out of that. So, all right. Rational function. That's a little tougher to visualize. We don't do too well visualizing that because we haven't done a lot of those. But we do have something that can help us visualize that. Got a graphing calculator, so we can graph that and check its one-to-one status. Okay, so being careful how we graph that. So we got to put parentheses around the top, 2x plus 1, divided by parentheses around the bottom, x minus 1. If you don't put those parentheses in the right spots, it's not going to do it correctly. So I'm going to hit graph. And we know that there is because it's rational, we've done a lot of stuff with rationals recently. What do we know about that function? What are the things that happen with rationals? There's asymptotes, right? What kind? It'd have a vertical one at x equals 1, and it'd have a horizontal at 2 over 1 or 2, right? Y equals 2. So if we look at that graph, we can see that happening. Here's our vertical one at 1, and then here's our horizontal there at 2. All right. So that horizontal asymptote, we know that when I lay that horizontal line there, that's an asymptote. So it's really not touching those lines, those blue parts, right? Does it pass the horizontal line test and the vertical line test? Yes, this is a one-to-one function. Okay, now, so one-to-one. Now, what we want to do is find the inverse functions.